Welcome back to another episode of the Hybrid Health Performance Interview Series, where we interview local Singapore experts on all things health, performance, and longevity. Today we have Dr. Vincenzo Sorrentino. He's a molecular biologist and researcher at NUS whose research looks at how our cells activate under stressful conditions, specifically during exercise. He's also an EMBO Global Network Investigator when it comes to things like mitochondrial dynamics, oxidative stress, and how exercise affects our body. For those of us that are hard at training like High Rocks or CrossFit, this conversation is really going to dive into what is going on within our cells when we're doing that kind of stress to our body. And not only how we can perform better, but how we can recover better. So I hope you guys enjoy this conversation today with Dr. Vincenzo. Your work looks at how our cells respond to physical and oxidative stress, especially kind of when we're like working out. So can you walk us through at a cellular level what is happening when we exercise?
Yeah, sure. So to put it in simple words, I would say there are several steps starting from the cellular level, which then go all the way to the systemic level, because exercise in the end involves the whole body, right? So let's say, for instance, you're training because you are interested, of course, in training your muscles, right? So what happens is that at the cellular level, once you start exercising, the first thing that happens is that in order to promote your muscles to work properly, the cells from the muscles will have to use ATP. So ATP is essentially the energy currency of our body, so it's the main way that cells produce and use energy. So what happens is within the first literally few seconds to a minute, the cells will use the ATP that is available in order to help the contraction of the muscle fibers, because that's a very energy requiring process. Then what happens next within, I would say from, let's say 1 to 2 minutes, and for longer training sessions, this ATP gets very quickly used up by the cells. So what the cells do is they use things like phosphocreatine, for instance, which is an ATP buffer. So meaning it's a molecule that can allow rapid regeneration of ATP without having to have, things like sugars or fat being burned yet. And that what allows the cells to quickly maintain the ATP levels for like another minute or two before it gets completely depleted. Then at that point, you start using, for instance, glycolysis, which means you start using sugars, which can quickly generate a few more molecules of ATP. But if you start doing above, let's say, already a few minutes of exercise and for long endurance sections, that's when the mitochondria come into play. So the mitochondria are the energy, let's say like the energy factories within the cells, which are the main producers of ATP. So what happens is that they would take more sugars, they would take fat, they would take other sources of, let's say, fuel, and they will convert it into ATP in order to make sure that your muscles can work. And this is only at the muscle level, right? So once you start, let's say, training for long sessions and so on, what comes into play is also adaptations at the level of the other tissues, meaning that your muscles are going to signal and communicate to the rest of the body that, for instance, you need to increase oxygen distribution to the muscle cells. So you need to increase, for instance, heart rate. The muscle will produce also sort of like molecules that signal to the body also for additional health benefits to promote endurance and so on. So you go from the very cellular level, but then there are systemic adaptations as well.
So it sounds like it's a very complicated, kind of involved process.
Exactly, yeah.
Right? And so you said a few things there that make me think of my high school biology class, right? So I always heard that like mitochondria are like the powerhouse of the cell,
right,
and ATP produces energy. So, when it comes to putting stress on these cells, how does repeated stress of exercise kind of increase the adaptation of them working?
Yeah, so that's the other step, right? So the essentially exercise, you can think of it as a controlled stressor. So it's something that actually causes stress to your cells, and in response to this increased energy requirement to adapt to the stress that is exercise, in addition to ATP, so if we want to go a bit more in details regarding how the mitochondria lead to generation of ATP, they require essentially oxygen in order to let's say, produce ATP. What happens is that in this increased oxygen demand, you actually generate also ROS. So ROS are essentially oxidative signals, which are sort of stress signaling molecules. So they're used during conditions of stress by the cells to talk to each other in a process called mitochondria. I don't know if you are familiar with this process. So hormesis is a word that means essentially a way to create homeostasis. So it's a signaling to create homeostasis. So it means that the cells communicate to each other, and within it, the cells as well, to sort of say, okay, there is a sort of mild stress which will activate now defense responses. So it's a way of adaptation. So, and in the case of mitochondrial dependent oxidative stress or ROS generation, we have mitochondrial process. So it's really related to the mitochondrial adaptation. So what happens there is that this oxidative stress signaling molecule, ROS, they are used and let's say by the cells and the other tissues to communicate this increased stress and this increased need for adaptation. And that's what actually causes the, let's say, your muscle cells and the other tissues to know that you're actually exercising and start generating things like changes in your gene expression of your cells. So to promote, for instance, more antioxidant response, but also to, for instance, signal to, let's say, transcription factors. So things that control the expression of your genes in the cells that you need to start producing, for instance, more genes and proteins that help more, for instance, the formation of new blood vessels to bring more oxygen to your muscles. So this process of mitochondria allows actually your body to respond to exercise from the cellular to the systemic level, and therefore that leads to this adaptation and increased endurance over time, because the more you do it, the more these signaling molecules will allow your body to essentially reset and to adapt to the stress. And therefore you're going to be, in the next sessions, you're going to be actually more adapted to the previous session, right? So you can actually go progressively higher and higher in your, let's say, exercise sessions, in the length of your exercise sessions and so on.
So in there, you talked about oxidative stress, right? Yeah. And so like, we work out, it creates that oxidative stress, but then our body produces antioxidants. And I'm familiar with compounds like taurine, which have antioxidant properties, right? So how does bringing in an external factor, in this case something like taurine, affect that oxidative stress process? Like, does it help us produce antioxidants quicker? Is it bringing in it externally and creating like a buffer? Right. Does it help us long term, or is it a short term reactant? Like, how does that work?
Yeah, so of course it's a very complex, interaction between any type of, let's say, external factor, can be taurine, can be other supplements or drugs, and the way that the exercise, your exercise regimen and adaptation to that works. In the case, for instance, of taurine, it has actually several roles. On one end, it has been shown to be a bit of antioxidant effect, but it also has actually like a more, I'd say, support in general to mitochondrial function. So on one end, perhaps, if you're taking, let's say, what happens with antioxidants, generally people prefer to avoid taking them before an exercise session or during an exercise session in order to prevent the blunting of this mitochondrial signaling. So you want your body actually to be stressed in the exercise session. But for instance, if you, for instance, are not going to exercise for a bit, or for instance in the recovery phase, so once you have already your adaptation phase happening, in that case, molecule like that can be probably quite beneficial in order to further support the adaptation of your mitochondrial function, right? Because you have the antioxidant response, but taurine has also been shown, for instance, to be linked to support mitochondria in generating more ATP, for instance. So you have on one end this antioxidant effect, but you also have perhaps more energy production, which especially in the phase of perhaps pre-workout or post-workout in the recovery phase, which anyways usually has to last 48 to 72 hours to allow also for your muscles to regenerate, build up and so on. That could be actually a good moment to use. So when you think of, kind of this post-exercise stress, but it ultimately, like you were saying before, it's like, you run a little bit, maybe it's kind of hard right now, but you do it more and more and more, it helps you, be able to run further over the long term. How long does that adaptive, stress response take to kick into the body? Yeah, so I would say, also that depends on your starting level. So generally, I would say for things to kick in terms of the molecular level, meaning protein synthesis, for instance, let's say you're doing strength training and so on, you do need like a good rest after the gym to actually allow your muscles to start activating, things pathways that are important for protein synthesis. Because during exercise, what happens is, in addition to the energy side, there is also a restructuring of your, let's say, muscles in particular, but also of the other tissues. So again, you have to allow your cells to produce more blood vessels for your tissues to be ready for the next exercise session. You have to allow your muscles to regenerate from these micro tears that you get during exercise, so that you can actually build more resilient and stronger muscles as well. And you have to allow also the protein synthesis to occur to maintain your muscle and tissues overall. So this is normally anything between 48 to 72 hours on average. Then of course, if you are a regular athlete that performs regularly, or just even a normal, let's say, exercise enthusiast, I think you can actually probably be much quicker also in those recovery phases, because then your body is already in the process, right? Because it's constantly taking care of that part. What's very important though, I think that's maybe what's a bit neglected sometimes from people, is that people are not so aware of the fact they want to get the maximum output in their exercise session, and then again the next day really hammer again very hard, right? I think actually the recovery phase is often considered like neglected, or like, oh, it's too long, I'm gonna lose my benefits. Actually, no, you really need that in order to maximize your benefits from your let's say workout sessions, which means you have to also be very aware of how your body performs, because everyone is different. The entry level or regular level of exercise, and how regular you are with your exercise is different. So it may be much less for someone to recover and much longer for someone else to recover. So that's also important to know and to listen to your body, and not overtrain, which would actually lead to, paradoxically, to counterproductive effects. You will lose the benefits, because you can even stimulate excessive muscle use, which is, it's going to actually make you lose strength, or make you reach this sort of plateau phase where you cannot really improve anymore.
Yeah, so I actually wanted to ask about, it sounds like the body kind of reaches homeostasis by itself, right? But we do need to support it. And correct me if I'm wrong, but it sounds like, maybe if you're just starting out working out, the recovery periods you need are bigger, but the more and longer you do it, the kind of quicker they get. Is that right?
Yeah, I mean, certainly. I mean, there's still a minimum that you need. You do need it. So that's why, usually also, things like sleep, for instance, same thing. Sleep is an important post-workout recovery phase, where actually a lot of this regenerative process occurs. So that's why, same as for exercise, but for everyday life, for all these processes, we always encourage people to actually respect them. So good sleep, good recovery after exercise, you need them. So there is going to be probably a minimum window, which again differs between people. What I'm just trying to say is, you should not reach a point where you just keep exercising without giving yourself any recovery phase whatsoever.
What maybe modalities that you've seen, either through like your research specifically or come out, can kind of help people maybe expedite or compound that recovery phase to, really support the body and kind of what it's doing under the covers, if you will?
Yeah, so I mean, again, there's several ways. I mean, there are, in my research, I focus a lot on compound-based or molecule-based interventions, right? So there can be natural molecules like supplements, or we are working also on drugs that are more in the longevity space, but of course those don't apply necessarily to everyday, let's say, to try to stay, let's say, fit and productive in your exercise. But there are also lifestyle interventions, right? So I think in my case, following more the intervention strategy, there are several molecules which are interesting in the longevity space, but that they seem to be associated at the preclinical level. So that's where I do most of my work. Preclinical level meaning more basic discovery and with some lab experiments. But people have started to do a little bit of clinical trials for these things that could boost essentially mitochondrial bioenergetics. So meaning like helping your cells to generate more ATP, or to maintain the mitochondria, so the machinery to generate the energy more functional, quicker, or over time. So you have several molecules that are considered interesting in terms of promoting mitochondrial biogenesis and recycling. So these are, because it's like when you are trying to maintain, let's say, your engine of your car functional, sometimes you have to replace some pieces, you have to oleate properly. So the molecules that I work with, for instance, are things called NAD precursors, or things that promote a process called mitophagy, which on one hand they help the mitochondria to be produced. For instance, after exercise or during exercise, you may get a benefit from these molecules because they allow mitochondria to be produced more and more quickly. And on the other hand, during exercise, again, due to the stress that you're undergoing you might get things that damage your mitochondria. So for instance, if you have mitochondria that are excessively damaged, you can use molecules that are, for instance, even commercially available, such as urolithin A or other molecules that stimulate antioxidant responses, which altogether would help to maintain this energy production ongoing. But again, this is some people use them for improving performance, but there is only minor studies at the clinical level for this. So it's important to also highlight that a lot of this, it's under clinical development still. So I would say it's really a discretion of people that want to implement this kind of supplementation in their regular life and exercise routine to also see if that's really what fits for them, because these are not drugs, right? So
So it's one of those things where the research looks interesting, but
exactly.
you know, we're not definitive on it yet.
Exactly,
right?
Especially when you're talking about performance or increased, let's say increased exercise, success or benefit. I think there is also, again, even things like lifestyle interventions and so on, you know, like fasting mimicking diets, calorie restriction. There's a lot happening also in that space, even coupled to exercise, you know, to see which ones are, for instance, more or less beneficial in terms of affecting your muscle mass, for instance. But that, again, it's gonna depend a lot on the person, on the type of exercise regimen that you're most interested to. So there's a lot of to work in terms of personalization, which will be critical.
Yeah. So, you know, I hear you talk a lot about, like, when it comes to mitochondria, like ATP production, energy production. And one of the first things it makes me think of, especially just, you know, from the health influencer space, is creatine. And I'd be curious, like, you know, you have the more deep science background, you know, what you think of supplemented creatine, right? How efficacious is it? And, like, you know, if someone were, you know, we'll say in the kind of performance side, like, where someone were to take it, is there like true benefit on the cellular level and, you know, energy production?
Yeah, I mean, I think, as I mentioned, you know, like for the ATP production, you do need actually the phosphocreatine, which is the, let's say, loaded version of the creatine to actually exchange rapidly and generate ATP. So in that sense, especially in conditions where, again, from the preclinical perspective, let's say in conditions that have been clearly associated with a decline of creatine and therefore muscle, let's say, worsening, like muscle atrophy and so on, supplementing creatine, especially creatine monohydrate, for instance, has been shown to be beneficial in sort of maintaining the mitochondrial energy production and therefore also preventing this loss of muscle function. That's always easier at the preclinical level. There's a lot of interesting evidence now also supporting the fact that it may even, for instance, be beneficial beyond supporting muscle health, for instance, brain health, cognitive health. I mean, again, these are all energy, high energy demanding processes. And as we age or in certain chronic conditions, these processes tend to decline. So in these conditions where there's a clear decline, let's say, of energy production, I think creatine and other interventions like that can be actually beneficial. At the clinical level, I think a lot of people have, there are several studies. I think there's a lot of studies showing it that has been linked to increased exercise performance and so on. Although I would say, as always happens with clinical studies, the more data you get, the more things sometimes can be complicated as well, because there is like one recent large clinical study that reanalyzed, I think, several data, and it was saying that actually this association between creatine and really increased performance may be very variable or not as strong or as canonically explained. But that's why I think what's going to be very important there is perhaps depends also on the level of depth that people want to go with their self-analysis. These things can actually be measured. So if you really want to be sure about what you need, let's say if you are interested in creatine or any other intervention, there are these kind of things you may be able to measure them, let's say through blood checks and so on. And in that case, then if you do see that you may be, benefiting from supplementing creatine, I think that case would make a lot of sense.
Yeah, I'd be curious. We've had a few of these discussions now on your just kind of general perspective of supplementation. I guess the way I look at it is I take some things kind of as like an insurance policy, right? The way I think of a multivitamin is like, it may just be making my pee very expensive, but it may actually be doing something in the long run. And so, when you think of supplementation, maybe whether it's for yourself or just kind of the way you look at the research, are you looking at it and go like, people should get blood work done to like target specific things? Like, are you on the camp that you can get everything from a diet? Or do you think of it maybe like me of like, the research is kind of there, but not quite. Like maybe you take it just in case if you can afford it.
So again, here there's several philosophies, right? I would say generally speaking, of course, if you can, the basics, right? The lifestyle interventions, if you can keep a healthy diet, regular exercise, and let's say like also good sleep hygiene and so on. Generally speaking, I would say for a normal, good, healthy life, you're probably gonna be, let's say, fine in that perspective. Coming to the fact of saying using this supplementation intervention as an insurance kind of preventative measure, I think there's going to be a few studies coming out and a few examples, for instance, that emerged indirectly though from studies done at NUS with these new, for instance, biological clocks developed by Jan Gruber and Feng Sheng from NUS, where they looked actually at things done from blood work from different people, not looking necessarily at supplementations per se, but what they were looking is that if you have, let's say, people that are having, let's say, predisposition to chronic diseases because maybe their blood checks, for things like cholesterol and sugar and so on are kind of not optimal. They are not, let's say, in disease state, but not optimal. They can already calculate that you have an increased risk of death. So meaning that your biological age is much, let's say, older than your actually chronological age. And what turns out to be in this new research that I've done is that they actually noticed that in people that were taking, for instance, statins or other drugs for keeping their cholesterol in check or these kind of things, they were actually performing in terms of biological clock or biological age even better than the people that were in their optimal range, which means, long story short, perhaps there's going to be more studies coming out that certain interventions may actually be either way more protective than detrimental, if anything. So that to say that we need more studies to be done, but especially with things that are considered safe, like some supplements and so on. Again, it's people's discretion, but there may be evidence popping up sooner or later that shows that actually they may have a slight preventative effect or ameliorating effect for the long run. But again, this is really up to the discretion of the people.
So my insurance policy theory may come to be true soon.
May have some foundation at least to some extent. But that's probably going to be my personal take, though. Again, it's really my personal take. I would probably also want to hear the opinion of different nutritionists. For instance, my personal take is that where this supplementation or let's say combinatorial approach of using different things would work is more on anyway still selected things like bioactives, so things like that would directly impact cellular pathways rather than, for instance, multivitamins that are really a huge mix of different things, but they do not come necessarily with the proper rationale behind their formulation, right? They're just very broad in their composition, and they may actually, in that sense, we don't know the interaction between all these molecules. They may actually also end up having not beneficial effect. They can cancel each other's effect. But with specific combined interventions, but that that can be based on proper scientific rationale, that could actually be where I think there may be possibilities to actually get this preventative or beneficial effect for the long run.
Got it. So like, I think the perfect example would be like going back to creatine, like an athlete taking it to help, ATP production and maintain muscle, right? It's very pinpointed thing. It's doing something.
Exactly.
And, it's not just someone who's sitting around and probably isn't, their body doesn't need the extra creatine.
Yeah, exactly. So again, you need to somehow, as much as possible, also coming back to your point of doing blood work. Of course, these are not things that are accessible, easy access or routinely accessible to everyone, but at least for some basic key readouts that we can get easily from blood and urine. I would say that's, if I try to do it myself just to know, for instance, things like vitamin D or vitamin B and so on. Like if these kind of basic things we can actually still check just to see how we're doing there and see if we need a supplementation or not, can still help you to be a bit more educated in your approach.
Yep. So thinking about your research and what we know now, right? Like what could you recommend to athletes when it comes to kind of like building a base of like kind of long-term health and performance? You know, normally when we're working out, we're thinking of kind of like, you know, our high rocks time, you know, Singapore high rocks is in 2 weeks, right? Like how much I'm going to bench press by the end of the month. But, you know, at the end of the day, we all want to be doing whatever activity it is that we like to do for as long as possible, right? So like based on, you know, your research or, you know, kind of what you read, how can we, you know, adjust, you know, either our lifestyle or our training regimens to, you know, make sure we're doing it as long as we want to be doing it? Yeah.
So I think in that sense, I think what I would say probably the key, I would say sentence here is probably that I like a lot is essentially that when you're thinking about this kind of stuff and how to do it, especially for long-term benefits, right? It's not just, about that specific sport event, but also how you do it afterwards, right? I would say when we think of exercise, and that's what I like for me at least, is to think about exercise as preparation for let's say, for adaptation, not for output, meaning that of course you want to reach a good level where you say, okay, I want to compete for that particular event in 2 weeks and I want to make it. But actually you have to think also, it's not just about that, it's about the adaptation response of your body, right? So you want to keep your body progressively adapting and not reaching this sort of stable plateau phase, which means in the short run it's good to push yourself and say, let's say I want to increase my muscle mass, my strength by increasing, you know, either the intensity of my exercise and so on. But then eventually you're going to need to find a way to, again, and this has to be to some extent personalized, on how to maintain that kind of stress and adaptation level between, you know, stressing your body through increasing, let's say, the load of your exercise or the intensity of your exercise, but also allowing it then to recover and adapt, right? So if you can maintain these two sort of growing together, you actually can probably think of very long-term adaptation and benefits without reaching this so-called plateau phase where you actually then struggle to maintain the benefit and you actually even seem to regress a bit, right? So I think that's based on again, I work more on the molecular level, but I think this from the molecular level makes a lot of sense because you want to maintain this, let's say you see like a mitochondrial process going on, and to do so you need to increase somehow your exercise intensity, the gains, the amount of cardio that you do, but also that means you probably need to also know or understand and work with, you know, with a specialist and so on how much recovery phase you will need so that you know that you're adapting to that, and then you can grow from there, right? You can build it as you go.
So what's like actually happening at the cellular level when you are, you know, always at that plateau, whether it's overtraining or under recovering?
Well, I mean, so in the overtraining, what happens is that you're actually gonna, you're not gonna let your body essentially create this, on one hand, defense responses to this excessive oxidative stress, and also you're not gonna allow actually your body to activating the pathways for, you know, things like making more protein for your muscle, right? So you're actually gonna end up in this catabolic phase, which means you're not building anymore, which is an anabolic phase, but you're actually gonna be more in the hypercatabolism. And that essentially leads to the opposite outcome because you're going to start essentially burning or degrading your own muscles in order to support this excessive exercise or energy expenditure, right? So that's a little bit what happens with this regression phase, right? With the plateau phase, I think at the molecular level, I think it's very complex. I think there's a lot of people studying specifically exercise physiology, but at that stage, you're still in a phase where you are not building anymore, but you haven't started degrading cellular components yet. I think it's probably a matter of, let's say, of signaling that doesn't get, let's say, it doesn't lead to further activation of your defense pathways or adaptation pathways. And so basically you are, still in a phase where, okay, at that point you're good, but you essentially cannot maintain this stress that then requires the adaptation to build more, right? So essentially you lose this synchrony.
So you lose both.
Yeah, you lose both in a way, but not to a point that is starting to be detrimental yet. You know, it's just that you cannot progress from there, right? So it gets stuck somehow. Yeah?
But then you're at that level long enough, and then it
then if you don't,
exactly.
If you don't, at that point, usually that's why people have to also create these strategies where you actually alternate, you change essentially your routine of exercise, you implement different strategies, different intervals. Many exercise physiologists, they even recommend, for instance, alternating periods of high intensity with periods of actually very low intensity or even rest, so that you really allow your body to fully recover, and then you can build again from there. So in fact, indeed, you know, if you exercise regularly, perhaps again depending on the people, but I think for instance in my particular experience, what I've noticed is that maybe the muscle tone or the muscle mass, you may lose it quickly if you don't, let's say, exercise for a bit. But when you go back to the gym and I repeat the same sessions, I actually realize that my strength hasn't really declined that much yet. So I can actually start from where I stopped, and then from there I can actually feel like, okay, I think now I've recovered enough that I can actually now try to build again from there, right? So there are things that you lose a little bit, but you can still build from there.
Now, when it comes to working out in Singapore, you know, obviously it's very hot, and hydration has become, you know, a pretty big topic, and obviously that's the space my company plays in. And you know, when it sounds like, you know, for this recovery process, the cells need a lot of support.
Right.
And like, what degree does hydration and supporting the cells with electrolytes come into play when it has to do with their recovery?
Right. Well, I mean, so in this case, I think for the hydration and electrolytes part is pretty clear, especially in climates like Singapore, or where you really have excessive loss of nutrients and so on from sweat, that you do need to reintegrate these kind of things, because essentially electrolytes, what they do, they allow better water intake and reabsorption at the cellular level, which is key, especially when you are sweating too much or too quickly. It's key for the cells to maintain essentially the osmotic level, right? So the normal amount of hydration and so on for the basic cellular function. Then on top of that, I think some of these electrolytes, they're also very interesting really at the cellular level, because for instance, if you take magnesium, just to mention one, it's quite interesting because it has also been shown to pretty much allow, so it binds essentially to the proteins, so to the mechanism within the mitochondria which allow for the ATP production. So back again to this energy production. So meaning that they allow more water to maintain your cells properly hydrated, and at the same time they also favor your energy production to keep going in a normal manner, right? So so for some of these electrolytes, I think especially during intense exercise sessions, if you want to do outdoor in Singapore, I think it could be actually quite helpful.
Yeah, I mean, something that I found interesting, when building out this product was, at least in the US, when you think of a hydration product, you think of Gatorade, if you're familiar with that, right? Which is really just a little bit of sodium and potassium.
Right.
And then, it's now quite prevalent, if you're in the health space, of how important magnesium is.
Right.
And I can't say, at least for a lay person, I was ever aware that it was really one of those minerals that was important when it came to hydration, let alone really important. Right?
Yeah.
I just thought that was interesting, but obviously from your perspective, it's like very important for the cells to do what it needs to do.
Yeah, certainly. I mean, of course, all these electrolytes, they all have different roles and functions and so on, but I think for some of these, there is even more the connection with the, let's say, energy production side of things, that is more connected than directly to the exercise performance or general functioning as well. I mean, magnesium is also important for other functions, for brain cognition during aging or disease. So I think, again, some of these micronutrients are quite broad in their effects, but they are often related to things that are important for highly metabolic processes that so energy related again.
So this will probably be the hardest question for you. But if you were to, kind of take, all the research you've done and package it into a piece of advice for athletes to help them not only, potentially increase their performance, but create that base of health span, what would you recommend that they do?
Yeah, well, indeed, it's a very complex question because I mean, again, my research is really focusing. I would say, in general, trying to combine. I would say certainly lifestyle interventions with as tailored as possible interventions that would help you to maintain your energy production within the cells as homeostatic as possible, meaning at the optimal levels throughout life, because that's where the challenge is. It's probably I would say on the long run is what will probably prevent and solve a lot of the problems related to not just exercise performance, but also staying functional as we age. I think because my focus is more towards aging, and it's pretty clear that as we age, there's clearly a lot of issues with your overall energy production. So mostly I focus a lot on mitochondria. So for me, I would say my piece of advice is anything that will help combining lifestyle with interventions that are proven to boost your mitochondrial bioenergetics would be, on the long run, something that will help a lot.
Yeah, awesome. Well, so my last question for you, and you can kind of take this wherever you want, is when you look at the space of whether it's, you know, kind of longevity, performance, supplements, maybe in your case, it's some more alternative modalities, I'll call it. What is the most exciting thing that you see coming up in this space?
Yeah, I mean, so there are several, I would say, you know, we like to think about these things. I mean, to make, of course, the interpretation easy for the lay public and also for the, in general, for other scientists that are not necessarily in the longevity or let's say, wellness space, is that we think of this, let's say, kind of health span, biologically speaking, and longevity as hallmarks, so different biological hallmarks, so different processes that become dysfunctional and that they need to be maintain homeostatic and in balance with each other in order to maintain both performance but also general health span. So for instance, for each of these categories, if you want, there is several interesting natural or drugs or lifestyle interventions that have been already shown or that they are emerging. I mean, for instance, again, I work a lot with things that modulate mitochondrial function, so things like NAD precursors, and things that also can modulate more like antioxidant responses. So some of these are mostly supplements. So, you know, people may be familiar with things like NNM or NR. These are so-called NAD precursors. They've shown a lot of preclinical benefits in terms of aging, even exercise performance, more blood vessel generation during exercise, which is important. And now they're being tested at the clinical level with, I would say, some mixed responses. So the clinical trials are, for the moment, small. Some show some positive trends, some show still some no big differences, but they are quite developing quite quickly. So this could be something interesting to consider. Things like, in my opinion, I think things linked more to muscle health, such as urolithinase or mitophagy inducers, they are quite interesting. They are already being tested also at the clinical level with some, again, positive trends. So more human data are needed, but I think this could be very interesting because they really modulate the balance of the formation and degradation of mitochondria. Then you have also molecules that are more related to generation of ATP from the mitochondria directly. So you have, again, vitamin B12. You have also some recent work from my actually ex-company where I worked before in Switzerland that has shown that things like from olive leaf extracts, for instance, they can actually directly help the mitochondria to produce more ATP without other changes. So which means you just make your engine more efficient without increasing the size of your engine in that sense. So these are all very interesting because they also offer room for combinations. Then there are things more related to cellular protection in general. So again, compounds that promote antioxidant defense, like glutathione, for instance, is one that is interesting. And compounds that also are related more to getting rid of cells, let's say the so-called zombie cells. So these are cells that especially after, let's say, during aging process with chronic inflammation and so on, they tend to accumulate in our tissues. And of course, they can also impact, for instance, in the muscle or other tissues. On the long run, they will impact how your body performs. So there are a lot of compounds called senolytics, which kill this senescence of zombie cells. Some of these natural, and they are, again, already even on the market, but there is clinical evidence is still to be developed. I think one that is also interesting is autophagy boosters, so the ones that take care of clearing the garbage, let's say, from your cells. For instance, spermidine is one that is now quite established to generate more, to produce more autophagy in your cells, and it's a natural molecule, so it's already, again, present on also as a supplement form. And I think people are trying to now test that in the context of also, let's say, exercise performance. Then, of course, we have drugs, of course, that people are testing for which you need absolutely clinical, you need clinical evidence, more clinical evidence for supplements, but at least with supplements, the advantage is that they are usually considered safe for use, right? So that's why you can think of this insurance or preventative intervention. But with drugs, there's a lot of interest in things like rapamycin, metformin, which have been shown to, with different mechanisms, to either, for instance, modulate, let's say, nutrient sensing. So meaning that, for instance, when your body has too many nutrients, it will activate so-called mTOR pathway, which when it's too much activated in that sense, it's actually been shown to be anti-longevity or not to be beneficial for, especially when you're an adult and in the case of aging. It's very important to actually to make more protein as you're exercising and when you're growing up, but too much activation, it's been also linked to chronic conditions. So what people are trying to do is to modulate it or find ways and either doses or intervention times to say, okay, when it's the right way to block this pathway so that you don't lose maybe the benefits of your signaling during muscle generation or sustenance, but it can actually ameliorate the induction of these negative processes. And for metformin, it's the same. I mean, there are large clinical trials now that are trying to understand if it's really linked to potential longevity in humans. It's still undergoing, but in preclinical models has been shown to some extent to be, let's say, associated with more longevity. And then, of course, I mean, there are, these different type of lifestyle interventions, which I think are interesting. So again, the different calorie restriction kind of approaches or fasting mimicking diets are interesting because what they do, they also induce your body to make more use of your own resources, for instance, fat, adipose tissue. And that, of course, can lead to your body to switch from, let's say, using more carbs and sugars towards using more fat and the generation of ketones, which are a way to essentially it's an alternative fuel that comes, let's say, also from burning of fats and so on, and that can be more efficiently used by your tissues. But you need to do a switch, meaning you have to first, your body tendentially will try to use sugars first. So this kind of diet interventions or supplementations with these ketone salts, it's kind of an interesting alternative approach. I think in some sports like cyclists, for instance, they tend to use things like ketone salts because they are a very quick way for your muscles to recover and use energy for your mitochondria. In the end, it's always at the mitochondrial level that they get used and then they generate energy, so ATP again. Then, I mean, people are going for very diverse approaches, like even physical things like hyperbaric chambers, cold plunges, saunas. For this, I would say they are all interesting because they seem to ameliorate or to change some of the parameters at the systemic level, such as blood pressure and heart rate and so on. Whether that's really more of a relief thing for, let's say, post-workouts and so on, and whether it can really support longevity in the long run, I think there's much more clinical evidence needed for that. So I think this is a little bit of several things. Then there's many more that we can discuss still, but these I would say are the first ones that come to my mind.
All right, so the actual last question is then, since you know a lot of the research around this, what do you do?
Personally, you mean?
Yeah.
Well, I mean, so again,
do you do cold plunge in the morning, NAD drip every day?
No, NAD drip. So that's So I work with NAD. So within the NAD space, so NAD drips, I always try to emphasize the fact that yes, I know in Southeast Asia and in some other parts of the world, it's very, I'd say, popular approach, but there is really no major clinical evidence yet for the benefits. So for NAD precursors, which lead to NAD production, at least there are some small but properly designed trials, and people are designing larger and larger trials. For NAD drips, there is very minor clinical evidence, and there's a lot of self-reported observations, which of course they lack proper scientific evaluation, and this is now I think something that needs to be done now. But personally speaking, so I try to keep regular exercise, like a mix of cardio and strength exercise, like 2 or 3 times per week without I mean, at least I'm not overdoing it. I do try to rest in between, so sleep properly and so on. But then in my case, for instance, I do try to use this approach of the insurance policy for the future. So I do tend to supplement with things like some NAD precursors, things that glutathione, for instance, for the antioxidant response, and also things that could be potentially beneficial towards boosting autophagy and get rid of senescent cells. So a mix of supplements that, for instance, contain, as I mentioned before, spermidine, or things that could be considered more senolytic, such as, for instance, quercetin and curcumin, to sort of make sure that at least at the cellular level, most of the processes that I'm worried about, they are actually supported, right? But I think what's really important is that I want to emphasize is that if one were to supplement without actually maintaining these healthy lifestyle habits, that's where I think things would be probably very shaky, I would say. So you do need certainly to maintain the proper lifestyle habits, so good diet, good sleep, regular exercise routine, and then maybe these supplementation approaches is where I think then they could be a plus, right? So I think that's what it works, what I like to think it works for me at this stage.
Awesome. Well, you gave me a lot more things to add to my iHerb cart.
You're welcome.
Appreciate the time today.
You're welcome.
If you want to learn more about our product, Hybrid Hydration, you can go check it out at hybridhealth.club or check us out on social media at Hybrid Health Co. You can learn more about how we use things like taurine, Rhodiola rosea, and creatine in our hydration supplement to not only help you perform better, but to help build that base of longevity, which we talked about today. If you want to learn more about some of the research that Dr. Sorrentino does, you can check him out at NUS Longevity.